physical quantities and units. So first of all, let's see what is physical quantities. So a physical quantity is something that you can measure. Okay, so it's a physical quantity. For example, like length. So you can measure it. Mass, you can measure the mass. So those are physical quantity. A physical quantity is made up of magnitude and unit. So from here you can see two parts: the magnitude, which is the value, and then the unit, you can see kg. Okay, the unit is kg, 2 kg is a physical quantities. Okay, so this is just basic. Now let's continue with 1.2, base units. Okay, so for base units, we need to know the followings. So the following are base units. We have mass, symbol M, length L, time T, temperature capital T, electric current capital I. Okay, so to remember the 5 base units here, normally we use T melt. T melt, T melt. So where the T stands for temperature. Temperature. This is temperature. One of the physical quantity, one of the base units, base quantities. The M stands for mass. The E stands for electric current. L stands for length, and then T stands for time. So this will help us to remember the base quantities or the base units here. Okay, so let's see the base units for the corresponding quantity. So kilogram for mass, kg, length meter, m, time in second, s, temperature in Kelvin, k, and electric current, ampere, a. So these are the base quantity. Then let's see here. All units except the 5 units above can be broken down to base quantities. So for example, let's say we talk about the units of speed. You know, speed is meter per second. So speed, meter per second. So we can break down to meter and second as 2 parts. Okay, so length and time. So we can break it down. Okay, now let's see the next part. So the next part is checking homogeneity of equations. Homogeneity. So what is that? We just want to check whether the equations are having the same units or not. Okay, so you see, if you are not sure if an equation is correct, you can use the units of the different quantities to check it. So that means you check the unit on the left, check the unit on the right. So the units on both sides of the equation must be the same. So if the units on both sides are the same, then we call it homogeneous. Okay, homogeneous. So homogeneity can be used to prove equations. An equation is homogeneous if base units on left-hand side are the same as base unit on right-hand side. So they must have the same base units. Okay, so this may not work every time due to the fact that it does not take pure number into account. Checking homogeneity doesn't means that the equation is always correct, because we have we don't take pure number into account. So for example, right, kinetic energy. Okay, so let's say try to write it here. Kinetic energy, the formula is 1/2 mv squared. We know that this is true because we learned that. If I change it to 3 mv squared, of course, I know it is wrong because we don't learn 3 mv squared, we learn half mv squared. So this is wrong. But in terms of homogeneity, they are still homogeneous. that means the base unit on the left and the base unit on the right are the same. Okay, are the same. So although they are homogeneous, but it's not true. Okay, so checking homogeneity have one weakness over here, okay, because it doesn't take the number into account. So this will make it wrong, make the equation wrong. Okay, so let's see one example again. When a body falls in a vacuum, all its gravitational potential energy is converted into kinetic energy. Okay, so by comparing units, show that the equation mgh equal to half mv squared is a possible solution to this equation. Okay, so let's see. mgh. Okay, so the unit for m, of course, is kg. The g here is gravitational acceleration, so which is the unit of acceleration, ms negative 2. The h here is m. Okay, so if I multiply all this, I will get kg meter square s negative 2. Okay, so I get something like this. And after that, we have to check the units for the half mv square. Okay, so the half itself no unit, so we start from m, kg. Velocity is meter per second square. Then we have kg meter square s negative 2. Okay, so by looking at the units on both sides, we realize that they have the same units. Okay, so they have the same units. So because of that, we can say that it is homogeneous. Okay, so we put something like this. mgh equal to half mv squared is homogeneous. Homogeneous, and hence it is a possible solution. You know, the unit must be the same. If the unit is not same, then for sure the equation is wrong. If the unit is the same, there is a chance for it to be the correct equations. Okay, so to know whether it is correct or not, we still need to do experiment to prove it. Okay, so this is about homogeneous. Now let's move on. Okay, 1.3. So 1.3 multiples and submultiples. So for multiple, we have 10 to the power of 12, which is tera. Symbol is capital T. 10 to the power of 9, giga. G. 10 to the power of 6 mega, capital M. 10 to the power of 3 kilo, K. 10 to the power of minus 3, this is under submultiples, they are taking negative power. 10 to the power of negative 3 is milli, M. Negative 6 micro, so this is mu. So this symbol is known as mu. Mu. And then 10 to the power of negative 9 nano, N. 10 to the power of negative 12 pico, and P. Okay, so these are the prefix and the multiples together with submultiples. Okay, so in general, we have to do it like this. If you have quantities with multiple or submultiple, you want to change it to quantity without multiple or submultiple. Multiple. So what we do is we multiply with the 10 to the power of something. Depends on which one. Okay, so if you have no multiple or submultiple, you want to change it to a quantity with multiple or submultiple, then we have to do backwards with divide by 10 to the power of something. So let's say, for example, if you have, let's say, 25 kilometer. Okay, I don't want the multiple, I don't want the kilo. So I multiply with, kilo is 10 to the power of 3. So I multiply with 10 to the power of 3 to remove to remove the kilo. Okay, so if you have, let's say another example, let's say you have 0.0005 meter. Okay, so this is the one without submultiple. So if you want to put submultiple to it, you have to divide by 10 to the power of something. So let's say I put 10 to the power of -3. Okay, so I divide by 10 to the power of -3. Then it will move 1, 2, 3. So I will get 0.5 millimeter. Okay, so something like that. Okay, so times and divide to make the multiple disappear or make it come out. Okay, now, yes.
Do I need to memorize like all of the prefix name?
Actually, yes, you have to memorize it.
Okay.
Yeah, have to memorize. Okay, so normally they will ask this in multiple choice. Okay, so have to memorize it. Okay, then let's move on. Even this estimation, you need to roughly remember the value. Okay, so for example, mass of a person about 70 kg. So if you say 700 kg is not suitable, so have to remember the rough value. Height of a person 1.5 meter around this. Walking speed is 1 meter per second. 1 meter per second. So how to remember this is the speed? Imagine in 1 second you maybe step forward, or one step. One step is about 1 meter. So that kind of idea. Speeds of a car on the motorway, 30 meter per second. So if you can't remember, then normally we are more familiar with kilometer per hour. So if 30 meter per second is hard to remember, so you just convert. Let's see. 30 meter per second. So you want to change it to km per hour. So you can just do like this. It's 30 meter per 1 second. Okay, so for meter, you want to change to kilometer. So you need to add the multiple. So to add the multiples, you divide. Okay, 30 divide by 10 to the power of 3 to change it to kilometer. And then for the second, you want to change it to hour. So 1 divide by 60, divide by 60 again. Then you will change it to hour. Okay, so after that, we just press calculator, and then you will get the units in km per hour, which may be more reasonable for us. Okay, so for this case, we will get 108 km per hour. So 108 km per hour. So that is kind of reasonable. So 108 km per hour. Okay. Now, volume of a can of a drink about 300 cm3. So if you look at the volume, I remember it's like about 325 ml for can. So 300 cm cube is reasonable. Density is 1000, density of water, 1000 km per meter cube. Density of air, 1 kg per meter cube. Okay, so this one is, you see, this is 1000 of this, 1000 times of that. So air and water, remember it together. Weight of an apple, 1 Newton. So 1 Newton is about 9.9 or 10 gram. Okay, it's about that. You know, W equal to mg, right? W equal to mg. So if this is 1 Newton, and then this is 9.81, and then you can just divide 1 divided by 9.81, and then you will get about 0.1 kg, 0.1 kg. So which is about 100 gram. Okay, 100 gram for an apple. Current in a domestic appliance, 13 ampere. EMF of a car battery, 12 volt. Hearing range is 20 hertz to 20,000 hertz. Young's modulus of a material is something multiplied with 10 to the power of 11. Okay,
What is something?
The something here is a number, you know. So it depends on what material you are talking about. So different material will have different value. So that's why in general they put something here. Something here. But the thing is, no matter what value is this, so it is around 10 to the power of 11. So you will learn Young modulus in detail later. So now it's just roughly first. Okay. Then let's continue. We also need to roughly know about the radiation's wavelength. Okay. So let's see. We have the gamma radiations. First one, gamma radiations, the wavelength is 10 to the power negative 16 to 10 to the power negative 11. Okay, so to remember these, you try to imagine this is about the size of an atomic nuclei. The nucleus of an atom. So the wavelength is about this size. X-ray, 10 to the power negative 13 to 10 to the power negative 9. This is about the size of an atom. Ultraviolet, 10 to the power negative 9 to 4 times 10 to the power of negative 7. So this is about the size of a molecules. Visible light, this value is about the size of a protozoan. Protozoan is microorganisms. Infrared, this is the size, and this is the size of a pinpoint. Wavelength is the size of a bee. Microwave. Microwave is the size of the bee. Radio wave. Radio wave is about the size of a human or the building. Okay, so and to remember this, right, there is a particular way. We use number to remember it. I start from 10 to the power of 1 to represent a rough value of the radio wave. Then you imagine the power, you minus 4, right? You will get 10 to the power of negative 3. And you see 10 to the power negative 3 is around about the wavelength of a microwave. Then you minus 2. You get 10 to the power of negative 5. This is about the wavelength of infrared, and then you minus 2 again to get 10 to the power of negative 7. This is about the wavelength of the visible light, and then you minus 2 again, 10 to the power of negative 9. Then you minus 2 again, 10 to the power of negative 11. Then you minus 2 again, 10 to the power of negative 13. So this is one of the way to remember the values. You know, kind of hard to remember. So this is the suggestions. You take it like this. Okay, so minus 4, minus 2, minus 2, minus 2, and minus 2. Now let's see the properties and the usage of each of these electromagnetic wave. So the first one, gamma radiations, produced by the disintegrations of atomic nuclei. So that means the nucleus break down or join up together. Okay, so very penetrating, causes ionization, affect living tissues. So we use this to kill the cancer cell, for example. Okay, now the X radiation, the X-ray, produced from rapidly decelerated electrons. That means the electrons slow down and produce X-ray. Property similar to gamma rays, the only real difference is in their methods of productions. So you see, gamma ray, you have to join up the nucleus or break down the nucleus, whereas X-ray, we have to stop the electrons to produce it. Now we have the UV light, ionizing radiations, affect living tissue, stimulates the production of vitamin D in animals. Okay, so ionizing radiation means they will make the molecules in the air change to ions. So ionizing. Okay, so visible light stimulates light-sensitive cells on the retina of the humans and other animals' eyes. So that's why we can see it as a colorful light. As a heating effect, this is infrared. Heating effect, and it's used for heating homes and cooking. Heating homes in winter, and then use it to cook. Microwave, used in microwave cooking where it causes water molecules to resonate. Also used in telecommunication, including mobile telephones. So this is the famous one. Our handphone use microwave. Radio wave, used in telecommunication. So like TV or radio. Okay, so I have done the estimation part, and we move on first. Okay, as you can see, this chapter 1, right? Nothing much left. So we still have scalar and vector. After that, you will realize no more. Okay, so let's finish it first, and then we will look at the past paper in details and to build up the techniques. Okay, so let's see, scalar and vector. So first, scalar has magnitude only. Okay, cannot be negative. So examples, speed, energy, power, work, mass, distance. These are the scalar quantities. Okay, so vector quantity, it has magnitude and directions, can be negative. So normally something like this, to the right positive, to the left negative, going up positive, going down negative. Normally it is like that. Okay, so example, displacement, vector quantity, acceleration. Okay, positive means faster and faster, negative means slower and slower. Force with positive value, normally to the right or going upwards. Okay, negative means to the left or downwards. So velocity, same also. Positive means right and up, negative means left and down. momentum, weight. Weight is downward lah, most of the time. Okay, electric field strength. So electric field strength we'll learn much later. Okay, now let's see 1.5 vectors. For vectors over here, okay, what we need to do is we need to break down the vector quantity here into components in order to solve it. So you can see acting vertically downward is the weight, which is mg. Okay, so what we need to do is we need to resolve into two components. So one is mg cos theta, another one is mg sin theta. So how they get these? So let's say I start from the basic. Okay, so first you need to know the theta is here. And this theta, when it bring it to the object, it will be here. The theta will be here. And after that, I can build a right angle triangle. One of the line is parallel with the plane. Another line is perpendicular with the plane. Okay, so this one, here is mg. So in order to find out this, right? So you need to know this is adjacent. Okay, so, and we know that cos theta is adjacent over hypotenuse. So the adjacent is what we need to find. The hypotenuse is mg. This is the hypotenuse. Okay, then adjacent is mg cos theta. So adjacent mg cos theta. Okay, that's why we have this. Whereas this one, this is parallel with the plane, or parallel with the slope. So in order to find this, you need to know this is opposite. So we have opposite together with this hypotenuse. We can use sine theta equal to opposite over hypotenuse. Okay, and then the hypotenuse is mg. So in order to find the opposite, we take mg sine theta. So we have adjacent and opposite found. So the opposite is hence mg sine theta. And then we have another force here. This one. This is the normal reaction. Okay. So let's see how we apply it for the technique that we built up here. So let's see this question. A box of weight 20 Newton lies at rest on a slope which is at 30 degree to the horizontal. Calculate the frictional force on the box up the slope. Okay, so imagine something like this. So you have a box here. The weight is 20 Newton. Okay, the angle here is 30 degree. Then you can bring the angle to this particular part here. Okay, then we can resolve it. We can resolve it to mg cos 30 and mg sine 30. Okay, then we have the normal reactions. Let's say I use different color, normal reaction. Okay, now we need to know also the frictional force is acting up the slope. Frictional force is acting in this direction. Frictional force. Okay, now the main concept here is the box is at rest. So at rest, that means the force are equal. Okay, so let's say the force which is in this direction, parallel to the slope. So we have 2 frictional force equal to this one. That means acting up the slope equal to the component of forces, the components of weight acting down the slope. So because of that, we have frictional force equal to 20 sine 30 degree, which is 10 Newton. So we get the frictional force. Okay, so far is that okay or not? Until here? Any questions?
Yeah,
Can,
no question.
So we have done the theory. So now let's see the past paper. Okay, so the past paper will be more important, of course. Okay, so I will just pick up a few questions as example, and after that, I will let you try the few also. I want to find out whether you are able to make it or not. Okay, so let's take a quick look on some of the past paper here. Okay, so let's say the first question. Which SI unit expressed in base unit is not correct? So when we want to do this, right, we need to remember the formula. So do you remember the formula of force?
Yeah.
So force equal to?
Mass times acceleration.
Okay, mass times acceleration. Then we know that the mass is kg, the acceleration is ms negative 2. Okay, so because of that, this is correct. Do you remember the formula for momentum?
Mass times velocity.
Okay, mass times velocity. So the mass is kg, the velocity is ms negative 1. So because of that, this is correct. Do you remember the formula for pressure?
Force over area.
Okay, force over area. So the unit of force, we have it here, kg ms negative 2. The area is meter square, meter negative 2. Okay, kg m negative 1 s negative 2. So this is wrong. So the answer is C. Okay, now let's do work also for practice purpose. Do you remember the formula for work?
Force times distance.
Okay, force times distance or force times displacement. Okay, so the force is kg ms negative 2. The displacement is meter. Okay, so we multiply them, kg meter square s negative 2. So that's why it is correct. Okay, now let's move on. Question 2. Question 2. Two forces, each of 10 Newton, act at the point P as shown. The angle between the directions of the forces is 120 degrees. So you can see the angle there. What is the magnitude of the resultant force? So you want to find the resultant force. There are 2 methods. So either you use triangle law, or the other way is parallelogram law. Okay, so triangle law is going to be something like this. Triangle law is you draw one of the vector and Newton. From the head of the arrow, you join up with the tail of another vector. You connect. Let's draw a bit more up here. So 10 Newton. So this is head to tail method of triangle law. Okay, so of course when you draw, you need to know the angle here from horizontal is 120 degree. And the resultant force is from the starting point to the end point, which is this. This is the resultant. And we can easily see that this is 60 degree. These two are 10 Newton and hence equal in length. Equal in length means these two should be the same angle, the base angle of isosceles triangle. Since here is 60, so 180 minus 60, we still have 120 for these two. 120 divided by 2 is 60. And end up with this is a equilateral triangle, and hence the resultant should be the same value because this arrow is same length with the rest. So it's still 10 Newton. There we go. So of course you can use parallelogram law. Parallelogram law is where we don't do head to tail. We don't connect. Parallelogram law, the idea is we just take from the same starting point, draw the 10 Newton and another 10 Newton. Then imagine we have a parallelogram in this particular way. Then the diagonal from this starting point again, we draw out the diagonal. So this diagonal is the resultant. And of course, to find this, we use the same concept. First, we transfer the 10 Newton over here, the 10 Newton. Then we use the same concept, 10 Newton, 10 Newton, and then here 60 degree, 120 degree, here 60 degree, and isosceles, same base angle, and end up with this is 10 Newton. So we still get the same answer. We just draw a parallelogram to help us. Now, let's see another one. Okay. Question 3. Let's take a look. An ion is accelerated in a vacuum by a series of electrodes. A graph of the power supplied to the ion is plotted against time. What is represented by the area under the graph between two times? Okay, so they tell us something that we are not familiar with. They talk about ion accelerated by a series of electrodes. So maybe you know this or maybe you never heard of this, but it's okay. Then they tell us a graph of the power supplied to the ion is plotted against time. So our graph is going to be like this. Power against time. And how is the graph? They don't tell. Okay, so they just say what is represented by the area under the graph between two times. So let's say you have one time here, another time here. Okay, so between this one, T1, and another time, T2. Okay, so let's say this is the area under the graph. So what is represented by this? They're asking something like this. Okay, so area under the graph. You have to use something like figure out the unit of the area to find out the suitable answers. Okay? You know, if I make it easier, right? just a rectangle. Okay, so power time. So to find out the area, basically you just use base times height. So the base multiply with the height, then you get the area.
Mhm.
Okay, so the base is basically the time. The height is the power. Power times time is something that we need to pay attention. Okay, so do you know the formula of power?
Work done over time.
Work done over time. Okay, yes, correct. Okay, work done over time. Power multiplied with time is basically work done, or power multiplied with time is something related to joule. Work done is in the unit of joule. Okay, so beside work done, it can be energy also. Energy is also in the units of joule. Okay, so by looking at the unit, we know A is wrong. Force. Force is Newton, right? So the unit have to be joule, so this is wrong. Change in kinetic energy. Kinetic energy is joule. Okay, joule. So this one, all right. Change in momentum. Momentum is kgms negative 1 mb. So by looking at the unit, we know it's wrong. It's wrong because joule, right? Joule is just now we discussed before. Joule, the unit is kg in this part. So work done, kg m2 s negative 2. So that's why C is wrong. Kg m2 s negative 2, which is not same with this. Change in velocity, ms negative 1. So by looking at the unit, we can quickly reject these three, and hence the answer is B.
Yeah.
So sometimes we handle it in that way. We don't understand what happens in between, maybe, but we are still able to do it because we look at the homogeneity concept. Okay, so let's see number 4. What is a typical value of the wavelength of a microwave? Okay, so maybe you feel like, oh, microwave, cannot remember. Then you remember it in this way. 10 to the power of 1 radio wave. Then you minus 4. Minus 4 is 10 to the power of negative 3. So this is microwave ready. So microwave is about this value, 10 to the power of negative 3, 10 to the power of negative 3 meter. Okay, so let's see which one is about this value. About this value, 10 to the power of negative 3 meter. Okay, so this one, picometer. So picometer is negative 12, 10 to the power negative 12. So you want to remove the pico. So basically what to do is we just multiply with 10 to the power of negative 12. Okay, multiply with 10 to the power negative 12. So imagine that 10 to the power negative 12. Then we press calculator. So we get 0. We get 3 times 10 to the power negative 6 meter. So which is wrong, negative 6. 30 nanometer. So we remove the multiples. We multiply with 10 negative 9. Okay, so 30 times 10 power negative 9. So we get 3 times 10 negative 8. So, which is also wrong. Okay, so A and B is wrong. Now we try C. C is micrometer. So micrometer, we remove the micro, we multiply with -6. Okay, so 30,000 and 10 to the power of -6. So we get
0.03.
0.03, yeah, which is -2. So very close to this one. Okay, so finally we have 10 to the power of -3 to remove the milli. So 3,000 times 10 to the power -3. Okay, so we get 3. This is wrong. So this is the closest. Okay, so we get the answer in this way. So you just need to remember -4, -2, and so on. Keep -2 until the end. Then you will get the rough value for the wavelength. Okay, so we need something like that. So let's start from question 1. Complete figure 1.1 to show each quantity and its unit. So you see speed, meter per second. So this one is done. So no problem for this. And the next one is density. So density, do you remember the formula for density?
Mass over volume.
Okay, correct. Okay, so rho equal to mass over volume. So the mass, kg, volume, meter cube. At the bottom, meter -3. So we get the unit. Okay, now you have to think of what quantity has these units as -1. Do you know anything on this?
Wait, let me.
Yeah.
I need to
Yeah.
send the file to iPad first.
Oh, I see. Okay, sure. Okay.
Frequency.
Yes, correct. So frequency is 1 over period. So the unit is 1 over second. So second -1. So frequency, frequency. Electric field strength, maybe you haven't learned this yet, or maybe you learned already in college. So electric field strength is force. The formula is force over charge. Over charge. Okay, so force, Newton, charge, Coulomb. Okay. Now the next one, kgms -1. So kg is mass, ms -1 is velocity. So we should think of momentum. Okay, momentum.
The unit is base unit or just unit in general?
It never mentions in specific. So base unit or just unit in general will be fine. As the question never specify whether to be base unit or not. Okay, so let us just move on. Question 2. State the difference between a scalar quantity and a vector quantity. So this is kind of simple. Scalar is quantity with magnitude. and no direction. No direction, but vectors is a quantity with magnitude and direction. Okay, so that's the basic one. Okay, so we just move on. Okay, so part B. Two forces of magnitude 6.0 Newton and 8.0 Newton act at the point P. Both forces act away from point P, and the angle between them is 40 degrees. Figure 1.1 shows two lines at an angle of 40 degrees to one another. Okay, so they expect you to use scale drawing to do it. Okay, to do it. So what we can do is they give us 40 degree already. So we are not going to use protractor anymore. So we set up the scale, something like this. You set up something like 1 cm, 1 Newton. Okay, then imagine that you draw a 6 Newton and an 8 Newton forces on this diagram. So we should expect one of the line to be 6 cm. You have to use ruler to measure 6 cm. And then you have to use ruler to measure 8 cm. So something like this. So 8 Newton, which is 8 cm. Then 6 Newton, which is 6 cm. Now we can just continue this with a parallelogram. This parallelogram law. So we draw another 8 cm and a 6 cm here. Okay, then you know the resultant is from the same point and form a diagonal in that particular way. Okay, so this is the diagonal, and the diagonal is the resultant force. Now you just need to use ruler. Use ruler to measure. Imagine that you're using ruler to measure the length of this resultant force. And let's say, for example, you get 13.2 cm. You measure and you get this. And then you have to say that this is 13.2 Newton. Then we get the answer, 13.2 Newton. So this is scale drawing. Okay? So we use scale drawing to handle it. So of course, sometimes they don't ask scale drawing. They expect you to use trigonometry to solve it. So which is possible also. Not for this question, I know. So if you are going to use trigonometry to solve the question in this particular way, so how are we going to do it? So we have to do something like this. Okay, let's say I just put it at the side here as practice. Okay, so we draw a 6 Newton followed by 8 Newton. So we use triangle law in this case. So you see the head is joined with the tail. So triangle law. So this is the 40 degree is between the two forces. So you should expect the 40 degree to be here. 40 degree. Okay. Then we get the resultant force by joining the starting point, which is here, to the end point, which is here. Okay, so this is the resultant. So this is 140. Okay, 180 minus 40 to get 140. So you want to find the resultant force. If you are not using scale drawing method, so we have to use cosine rule. So cosine rule, FR power 2 6 square x square minus 2 6 8. Are you familiar with this formula? Cos.
Yeah.
Yes, huh? Okay, then this calculator, press calculator, and we get 173.54. Then we square root to get the resultant force as 13.2. Okay, so we can use trigonometry method to handle it, or we can use scale drawing to handle it. Okay, so let's see more questions. Okay. Let's look at this question 3. A student has been asked to determine the linear acceleration of a toy car as it moves down a slope. He set up the apparatus as shown in figure 3.1. Okay, so the toy car moved down the slope. We have the distance. The time t to move from rest through a distance d is found for different values of d. A graph of d is plotted against t squared, as shown in figure 3.2. Okay, so we have a graph d against t squared. So it's a straight line graph. So this graph is given. Okay, now theory suggests that the graph is a straight line through origin. But if you look at here, this is not through origin. It's a little bit away from origin. Okay, now name the features on figure 3.2 that indicates the presence of random error. Okay, so this random error, right, is the next chapter. So we haven't learned this yet. Okay, so let's say I skip this question. Okay, I don't want to do this first. Okay, let's skip to the other one. Question 4. Make estimates of the following quantities. Okay, so let's see. A. The speeds of sound in A. Speeds of sound. Okay, so speed of sound in A, 3 digits. You have to know that speeds of sound in solid is the fastest. Okay, so in air is the slowest. In liquid is moderate. So this is about 300 meter per second. The density of air at room temperature and pressure. Okay, so this value is in the note just now. If you still remember, it's 1 kg meter negative 3. The mass of a protractor. So you have to imagine your plastic protractor about 10 gram.
How to imagine?
Sorry?
How to imagine?
Yeah, there is a range in the mark scheme, So it's about this. Okay, so there is a range. And D, the volume in cm cube of the head of an adult person. So imagine, they may ask something like this. Adult person. You can't cut your head and put inside the water to get a volume, right? So you have to imagine in cm cube. Okay, in cm cube. So the head of an adult person is something like, just imagine. It's something like, okay, try to imagine. It's about 20 cm. 20 cm is about 20 cm. Okay, so volume. So is about 4 over 3 pi r cube, the volume of sphere, you know. So where the r is about 10. Okay, so if I use calculator, 4 over 3 times pi times 10 cube. So I get about 4,000 something. 4,000 something. So about 4188, you know. So what they give about 3,000. Okay, so it's around that, you know, 4 digit. So you see they may ask something like this, and 4 marks, you know, so 4 marks for just estimation.